Hey, Clayton, we're on 6-2. We're going through the notes. This is going to be a quick section because this is all stuff that we've done before. Two things, though. The triangle sum theorem means that all of the angles are going to add up to be 180 degrees. And if we have a right triangle, we can use the Pythagorean theorem to find missing sides, like this one. Okay, so like if we didn't know that this was 5, we could do a squared plus b squared equals c squared and solve it that way, okay? Let's go down here to example 1. We have 65 degrees, we have x, and we have 8, and we are solving for x, okay? Yesterday we did SOHCAHTOA stuff. If you need to write SOHCAHTOA down next to this problem or at the top of your paper, please do so. I'm going to. SOHCAHTOA. And yesterday we did all 3 of them, or sometimes we did all 6 of them, right? Like cosecant, secant, cotangent. Right. In this section today, we're only going to choose one, but we have to choose the right one, okay? Because some of them are not the right one. Well, and the way that we're going to do this is we're going to start with the angle, and we're going to look at the other 2 sides that we have, or the ones that we're solving for. And what is x in relationship to 65? Adjacent. This is the adjacent, and 8 is the hypotenuse. So we're going to use whichever trig function uses a and h, which is cosine. All right, so we're going to do cosine, and we have to do cosine of something, and it's always 65. The angle. So cosine of 65 equals, and we do a over h, right? X over 8, and then we solve, okay? So if we're trying to get x by itself, we multiply the 8 to the other side, and we have 8 times cosine of 65. Practice typing that in. 3.38. Because some of you guys might have your mode switched again.
Is it supposed to be degree or radian?
It is. What is it supposed to be? Degrees or radians?
Degrees. 3.4.
65 is a degree.
But I don't know how to change it on this calculator.
Oh, I don't know. I don't know.
Do you have another one?
3 point what?
4.
3.4?
Whoa.
No.
Why did I not get that?
Because you're not in the right mode. Okay, here's what I want you to do, okay? Go to mode, which is next to the blue button, okay? Go down, like the third one down where it says radians or degrees. You want to switch it over to degrees always, okay? Later on in this chapter, and hit enter, okay? Yep. Later on in this chapter, we will be switching to radians, okay? So you need to know how to switch back and forth.
What am I going to need for the ACT?
Right, degrees. Always degrees for ACT. Never radians. Always degrees. Okay? So 3.4 is what x is. Always kind of see if that makes sense. 3.4 is what this guy is. Okay?
Hey, I think
8 should be the biggest side. So we know that it's not any bigger than 8. 3.4 seems pretty reasonable. So there's that. Okay? Example 2. Find the measure of angle theta. And we have this guy right here. This is harder than the one above it. We have angle theta, and we have options. We can choose which trig function because we know all 3 sides, right? So 3 is the opposite. What's 4?
Not hypotenuse.
Not hypotenuse. It is the adjacent. Hypotenuse is the bottom because it's opposite in the 90.
3 over 4.
Okay, so which one do you want to do?
Tangent.
You want to do tangent? You want to do 3 over 4? Okay, so we have all 3 of them, so we have any option we can do this different ways. Emma wants to do tangent, so she's doing tangent, but tangent of what?
Theta.
Tangent of theta equals, okay, just wait, we're going to set this up. No.
That's what I meant.
Okay, tangent of theta, this is different than what we did before. Tangent of theta equals opposite of our adjacent, which is 3 over 4. Now, here you go. To get this to go away, to get the theta out of there, to get the tangent out of there, we cannot, watch this, we cannot just divide tangent over, right? We can't divide by tangent because the theta is stuck inside of tangent, right? So to get this tangent to go away, we do inverse tangent because that cancels them out, right? So theta is equal to inverse tangent of 3 over 4. Now, how do you inverse tangent?
Second.
You hit second tangent. Okay, everybody practice typing it in. Inverse tangent of 3 over 4 because if you're in the wrong mode, you're going to get the wrong answer. And how many degrees do you get?
36.9.
36.9.
Okay, go to just one decimal place on degrees. 30, but we'll just do one decimal place, period. How about that?
Right.
Degrees or sides, doesn't matter. 36.9 sounds good to me. 36.9 degrees. Okay? All right, let's go down to the next one. Solve the right triangle in the figure. Okay, when it says solve the triangle, what are you solving for?
All of it.
Everything. You're solving for all the things, okay? The 3 variables that we don't know are A, B, and theta. right?
Theta
Okay.
is 15.
Cray says theta is 15. Is he right?
Yes.
How does he know?
Because 90 plus 75 equals something.
Those add up to be 180,
Minus 180,
right?
Yeah.
Or really, if the one corner is 90, then these two add up to be the other 90, right?
Yeah.
Okay, 90 minus 75 is 15. So he is right. Theta is 15. Make sure you label it as degrees so we know that it's an angle. And then we need little a, little b. Okay. How do you want to solve little a? Let's do little a first.
Cosine.
Okay.
Take a shot.
So are you looking at the 75? Amakar? Are you working with 75?
No,
I think it's probably
What are you doing?
14.
I'm working with theta.
Why?
We know.
I'm doing
So we know that theta is 15 degrees, right?
sine of 15 equals.
So could you use the 75 or the 15?
Yeah.
Okay. Typically what I will tell you is
that
always
you
use
should use 75 because it was already there and you didn't solve for it already.
right. But 15 is not rounded. 15 is what it is, right?
Right.
If
So
we
you
would have
can't-
rounded the number, I would say don't use it, right? Because then your other answer is even further rounded. But we could use either one. It doesn't matter because 15 was not rounded, right?
Because I want to use 15.
You go for it. Okay, you use 15. We're going to use 75. 75, if we're solving for little a, we have to use a and what else?
What are we doing? Cosine?
17, which is opposite and 17 is the hypotenuse, right?
Sine.
Okay, so we're going to use sine.
We're not doing
Whoa, I'm writing over here. Sine, this is hypotenuse. So sine of what? 75 equals, the opposite is a, the hypotenuse is 17. Are we confused what we're doing?
Nope.
If you're confused, stop me because I'm going through this a little fast because we've done this before, but if this is confusing, I will stop and go slower. Multiply the 17 over, so take 17 times sine of 75. And what'd you get?
16.4.
16.4 is A.
Oh, and that's B too. How ironic.
What?
What?
No.
16.4 I got.
No.
That's what I got for B.
No, you didn't do it right.
What did I do wrong?
You did sine of, make sure you're doing sine of 15.
Oh, I did 75.
No, for B, I did opposite.
You did opposite hypotenuse, but you're doing sine of 15, not
I
17.
clicked the wrong button.
Sine
You clicked the wrong
75.
button, I think. Okay, now let's use 75 again, but now we're gonna do the B one. Okay, and we know that A is 16.4, and we know that this is 17. Okay, so I'm using 75. I have to use B, and B is what? B is adjacent. Okay, now we need one more side. Are we gonna use the 17 or the 16.4? Use the 17 because 16.4 is rounded, all right? So we want to do A and H. So cosine of
What else is done?
75 equals B over 17, and then multiply the B 17 over.
She didn't.
17 cos
She said
75.
That's what I mean.
17 cosine of 75.
4.4.
4.4. Okay, let's check this out and make sure that this seems reasonable. 4.4, okay? 75 is opposite 16.4. 15 is opposite 4.4. Does that seem reasonable?
Sure.
The small angle's opposite the small side, the big angle's opposite the big side. Did I tell you that in geometry? Maybe, probably. Okay, there you go. Those are the things that we don't know. That's what we're solving for. Go to the next one. Solve the right triangle in the figure. How about you do this one?
But this looks like a 90, 30, 60, 60.
I don't think,
no.
maybe.
How about that?
5, 12,
Okay.
13. Oh.
How about you do it,
What about
and
you?
I'll do it at the same time, and you check with me, okay? So, everybody be quiet. Solve this one. I will solve it at the same time, but don't look at mine until you have an answer. Go.
Okay.
You do know how to find A? Yeah? Ooh, you're going to find A different than I would have, but I'm going to find it the way that you do.
Is it an Anki number? Because that's what I got.
Yeah,
Why
that's
would
what
you
I
not do it that way?
I originally in my head was like, let's solve an angle and then let's do SOHCAHTOA. Nope, let's not do that. I need a calculator though.
Oh man, I'm beating you.
You are not either.
Yeah, I am. Actually, I am.
You're not gonna.
I beat you.
You're done.
Yeah.
You're a cheater.
I'm not a cheater. I did it. I did that.
I'm done, Comacher. I beat you. Loser.
I beat you, so.
Well, I beat Coacher, so that's all that matters. Because she-
Well, I know what this answer is supposed to be because cosine is 1/2 at 60 degrees. So this is 60 and this is 30. But if I show my work,
What did
I showed my work too.
What did I
I'll have
say?
you know I didn't even do that. I just figured.
Did I
it was
not say a
60,
60, 30,
and I
90?
wrote it down.
yeah,
It's 45, 45, 90.
right.
1, 2
I'm
squared.
guessing, actually.
1, what is it?
You guess.
1
Well,
squared
I
to 2 and
did the bottom one. But
2
I
squared.
just guessed on the 30 and 60.
Would you not?
Yeah, this how Kelsey covers her cough.
She didn't even try to cover it. She just straight up coughed.
Nobody's finding. How can you do it?
Cough in your computer. Mallory, how was your slinky?
Okay.
I sound like you're trembling.
All right. If there's people still going, be quiet for them.
I go,
Yeah, I think I'm gonna start my homework.
Me too.
You just wait.
To be frank with you.
You can start working while now we're getting into like the actual. You have to draw this and find it. So you want to wait and listen. You can start right now, but
Sweet.
Okay, Coacher.
stop when we come back to you.
Just, do you make these or does it just give you this?
I do.
You make it? Could you please?
Don't yell at me.
I'm gonna.
Why?
I need individual triangles for all this because I gotta
We don't care.
write
Then
it
draw
all.
them.
Well,
yourself.
Then I gotta write it all in, then
Then
erase
draw
it.
them yourself.
But I'm not good at drawing triangles.
Oh my lord, child.
I'm not in geometry.
Your
But you've
child-
had geometry,
Your
so.
child took my mom's phone and put tape all over it.
feels pretty funny.
My child, in like a half of a block, driving from Dick's Grocery to our house, took Carmex, one of those little Carmex tubes, and smeared it all over my window, up in the corner. I didn't notice it until like an hour later, and I look over and I'm like, what is on there? It looks like somebody like snotted all over the thing in like a little corner, but it's like kind of like in like a little box or whatever. Nope, she took the Carmex, and I looked over and I'm like, oh, there, it's sitting right there. Yep,
That's funny.
in half of a block.
She's so nice.
Does it come off?
I was just being
I don't know. It's like grease, so I'm gonna have to like use
New one.
alcohol to get it off. I haven't wiped it off yet. It's still there. Huh?
18, do I just put on
Yes. Because it's 0 divided by 1 or whatever it is. 1 divided by 0. Yeah, undefined. Yep. Okay, are we ready for the backside? Moving on. Can we move on? Are we ready? Example 5. Heights above sea level. They give us this triangle here. At some point, you might have to draw your own triangle, maybe on the homework assignment. I don't know. Yeah, 13, you'll have to draw your own picture. So here you go. A straight road leads from an ocean beach at a constant upward angle of 3 degrees. How high above sea level is the road at a point 1 mile from the beach? So we're solving for like this side of this triangle. And they represent 1 mile in feet because they want our answer to be in feet. So 5280 is that side if you want to draw this a little bit better with not quite as much of a slope. We're trying to solve for this, and this is 5280. So we just have to figure out what trig function we're using. Here's 3 degrees. What's x?
Opposite.
Opposite and
Hypotenuse.
hypotenuse.
Sine.
So sine of
X.
3 equals
Oh.
x over
Over
5280. Okay, so I just multiply the 5280 over. And 5280 times sine of 3 is what x is, whatever that is. It's not very much. If that's only 3 degrees, it's not going to be very high. What?
not what I got.
What'd you get?
So
276.
52, 80.
That's fine. That's fine. That's not very much in comparison to the 5,000, right? 200 and something is not very much in comparison to the other one.
So
To what?
equals 276.
Point
0.3.
0.3 feet. Okay. Yeah, I should have specified more. 276 in relationship to 5280 is not much, right? Because it's only 3 degrees. Okay.
Wait, when it says solve the triangle, you want all 6?
Everything. Yep. Example 6. Really the only 3 that are missing, right? Because they have to give you 3 already. But you can label them all out. Example 6. According to the safety sticker on a 20-foot ladder, the distance from the bottom of the ladder to the base of the wall on which it leans should be 1/4 of the length of the ladder, which is 5 feet. So your ladder is here and it's 20 feet. And if it has to be 1/4 of the distance away, then that has to be 5 feet, right? If it was 24 feet, it would have to be 6 feet, etc., right? Going all the way. Why do they specify that? Why do they do such a crazy thing to specify like it has to be this far away from the ground? Why would they do that? Why would they specify it has to be 5 feet away from the wall? Because if I move it closer, right, and I do my ladder like this and move it closer, right, then by me climbing up the ladder, by the time I get up to the top here, the weight might pull it this way and I could fall down, right? Like the ladder fall off the wall.
Like in
Right.
Hannah Montana where her dad
Right.
or her brother falls off the ladder.
Or like
and
any
she's born.
Christmas movie you've ever seen where they're putting lights on a house. Like that happens in a lot of them, right? And they fall into the bushes or whatever, you know. So they specify that. They say how high up the wall will this hit. So meaning like how high or what is the length from here to here, right? So we have to figure out what, how high up the wall will the ladder reach. How do we find that? How did you find it?
I took 20 squared.
Okay, so you did the
minus 25.
Pythagorean theorem, right?
Yeah, that.
A squared plus B squared equals C squared. The wall is which variable?
The adjacent.
B.
A or B, it doesn't matter which one you use. It's not C. C has to be 20, right? Okay, so let's say A is 5 and B is what we don't know. 5 squared is 25. 20 squared is 400. And then what? Minus 25. 400 minus 25 is 375. And then we take the square root. B is whatever that is. 19 or 18, something. 19.4 feet. Okay, that's how high I can reach is 19.4 feet. Okay? If the ladder is in this position, what angle does it make with the ground? So we are solving for theta. All right, we know that this is 19.4, and we want to solve for theta. But which two sides do you use? We're not going to use the 19.4 because that's rounded. We're going to use the adjacent and the hypotenuse like Rachel said, right? Because 5 and 20 were given to us. We know those exact. So which trig function do we use? Cosine. Okay, cosine of what? Theta equals adjacent over hypotenuse. Okay? And we do the inverse. So inverse cosine, inverse cosine. Theta equals, what is inverse cosine of, oh wait a second, 5 over 20 is like if you would by chance reduce it to 1 over 4, can you do that? Can you do that to make it less work to type in, right? You could certainly do that, or you could type in 5 over 20, it doesn't matter.
5.5
Degrees, 75.5 degrees. That's what he is at the bottom left corner with the ground. Okay? All right?
On jet.
Last thing. They have angles of elevation and angles of depression. So when they're talking about an angle of elevation, they're talking about in relationship to the horizontal distance.
This is the last.
If you elevate, you raise up. This is an angle of elevation. If you depress, you go down. And that is an angle of depression. Yeah? So when they're using that terminology, especially if you have to draw this yourself, elevation is going up, depression is going down, all right? So, example 7, a flagpole casts a 60-foot shadow when the angle of elevation to the sun is 35. That's why it's here. With relationship to the horizontal distance, the angle going up is 35. Yeah? 35 is that angle. Okay. Find the height of the flagpole. Woo. Opposites, adjacent,
Tangent.
tangent,
Of
tangent, 35 equals opposite, adjacent, h over 65, then, or 60,
60.
then what?
Times 60 times 60.
Yep.
60
H
times
equals 60 tangent 30. 42.08 feet. Oh, 0.01 feet equals the height. Okay, question. Hold on. Don't stop yet. Ready? What happens if instead this would say tangent of 35 equals 60 over h? We didn't have one like that. I was hoping we would. What happens
You moved
if
the
the h is in the bottom?
Still have
You
to do
divide by
R.
tangent 35.
So what you can do is if the h is in the bottom, these two end up swapping out with one another. So h will be equal to 60 over tangent 35. Right? That's how that works. Those two swap places. So the h is on the left and then the tangent 35 is on the bottom. They didn't give us a problem like that. I was hoping that they would because you might have a problem like that on your homework. But if that's the case, you just swap those two and then you divide by the trig function. Okay? All right, good? Okay, this shouldn't be too hard. 6-2 homework, when they say solve the triangle, find all of the other three things that you don't already know. Okay? That's when yeah. So like on, I don't know. Yeah, on 9 and 10. You have to find the other things that you don't already know. Okay?
6, 8, 10 a perfect.
No. Oh, yes, it is because it's a 3, 4, 5. Right. Okay, goodbye, Clayton.